It is helpful for us to visualize energy changes and what's happening throughout a process on what's called a reaction coordinate diagram. This is a reaction coordinate diagram for the reaction shown at the bottom, where we start with HO- and CH3Br, and then at the top we have this transition state of HOCH3Br, and then finally our two products, CH3OH and Br. The diagram shows the energy of the reactants and the products. So at the beginning, this is the energy of the reactants. At the end, this is the energy of the products. And so you can see by this red line here, the change in energy for the reaction is shown on the reaction coordinate diagram. The highest point on the diagram is the transition state. The species present at the transition state is called the activated complex. So we can see visually the activated complex here, or in its equation form there. The energy gap between the reactants, which are here, and the activated complex, which is here, so the energy between those 2 points is called the activation energy. What is the significance of the activation energy, that energy between the reactants and the transition state or activated complex? Well, in order for a reaction to occur, a minimum amount of energy must first be applied to the reactants. That minimum energy input is usually what's needed to break the bonds of the reactants and allow the reaction to go forward. So that minimum amount of energy is called the activation energy.